Find the velocity and the position vector given that a is 12ti plus 80t cubed j, that's the acceleration, and that when t is 0, the velocity is 3i plus 7j, and also when t is 0, the position vector is 2i plus 11j. So both these two conditions here are from when t is 0. So find the velocity and find the position vector given the acceleration. We're going to be doing some integrating here. So first of all, if we integrate acceleration with respect to time, don't forget the dt, that's going to give us the velocity. Very important you remember the constants. I've used a couple of ways of setting these out in this series of videos. I'm sure you can cope with the two different ways and choose which one you prefer. In this situation, I've decided to put the C1 straight in there with the I component and the C2 straight in with the J component. So that's the velocity, but there's a couple of unknowns here, so let's find them. Using the boundary condition that when t is nothing, v is 3i plus 7j. So we're into this line, remember it equals v. Another way I could have represented v is r dot. Also acceleration, you could have represented that with r with two dots, r double dot. Anyway, going back to this, if we sub in our boundary condition, we get C1 is 3, C2 must be 7. So now we have the velocity. That's just this line again with our C1 and C2 subbed in. That's part of the answer. Find the velocity at any time t. So that's first part of our answer. Let's keep going now to get position vector. So integrate this. So integrate the velocity to get the position vector. Again, I've gone with putting the constants straight in there. I could have put them on at the end, but in this case I haven't. Make sure you use different names. Don't go reusing C1 and C2. So all this equals R. We've got another boundary condition. When t is nothing, R is 2i plus 11j. If we sub that in to the line above, we get C3 is 2, C4 is 11. So now we can give the second part of the answer, the position vector in terms of t, and there it is.